Yes guys, so today we are going to discuss about Maven tool, how it helps the developer. Basically Maven is a development tool. So what kind of problems it solves? Now to understand that, we need to first understand what is the basic application development life cycle. Okay, when we say that developer develops the application, so he doesn't only write the code, he has to do few other things as well. So that entire development life cycle Maven helps us in. So today we are going to discuss about that entire development life cycle and different phases of it, and then let's understand how Maven helps in that. So when developer develops any application, of first and foremost thing what he does is, if he needs any third-party libraries in the sense, let's say I am developing an application, and for developing that application I need few jar files, right? Like there are few classes. Let's take an example of Java. So if I am developing a Java application, in my application I want to handle Excel files. For example, I want to write data into the Excel, I want to read data from Excel. So to handle Excel files, what are the class, whatever the methods are required, those are not part of a regular Java library classes, like the classes which we get along with the Java environment. So those don't have the methods or don't have the classes to deal with the Excel files, right? So developer relies on a third-party classes. Third-party classes is as in the classes which have been developed by the developers, right, and not part of the Java environment. Those are third-party, right? So any developer who wants to develop an application, he needs to first download those third-party libraries before he can start implementing his logic. Now the question is where he can get those jars from, right? So let's go and check one important website, that is MVN repository. Now this is a public repository which hosts different third-party Java libraries, like the developers who develop reusable code, something like handling Excel files or any common problem if any developer is solving, right, and he is writing a logic for it, he is writing libraries for it, then that developer may opt to release those jar files onto this platform, which is a public repository where we can get various libraries over here. Now let's take an example of as I said, Apache POI. So this Apache POI is the library for handling Excel files in Java. So you can see there is a group called Apache POI. So this is one of the group who has developed this particular library. Okay, so they have released those libraries over here on this particular platform, which is a Maven repository, a public repository which anyone can access, anyone can download the libraries from. You can see here there are various versions which have been released so far for this particular library, right? Now if you go on any of the release, let's say if I have clicked on here and if I see, so this is the particular page which describes about a particular version of a given library. Now you can scroll down and you can see that this particular library has got few dependencies. Dependencies in the sense, this particular library uses the classes, methods from some other libraries, right? Few other libraries. Let's say, let's take an example as I am developing library A. Now for developing this library A, I need a few classes from library B. So this library B becomes dependency of library A. Say this library B depends on some classes implemented in library C. So A depends on B, B depends on C. So this is called as recursive dependencies. Right? Now you can see here the Apache POI, it depends on, it has got few compile time libraries like which we need at the time of compiling the application. It's called compile time libraries, right? And there like few applications also have runtime dependencies, but this particular doesn't have any. But I'm just telling you, like there are three kinds of dependencies. I have already explained it here in this particular document, but just as we are discussing about the libraries and dependencies, so we need to understand this. There are three types of dependencies. Always remember: compile time dependencies, then test dependencies. We will talk about these test dependencies once we will write the unit test cases for our application which we are going to start building. And third is runtime dependencies. Okay, so compile time dependencies are those which we need at the time of compiling an application. Test dependencies are those jar files. Let's take an example as those we need while performing a unit testing on that particular application. And runtime dependencies are those which we need while executing the application. Okay, so your application might have either all of the three dependencies or any of the three. It depends upon what kind of application you are developing. Now the application which we are going to develop, it has got mainly these two types of dependencies. One is compile time, not even compile time, we only have one, that is test dependency. I'll talk about it once we will write our application. Okay, so in this case the Apache POI, it has got compile time dependencies. Like when the Apache POI developer has developed this library, he needs these jar files at the time of compiling his Apache POI source code. So that is why these are compile time dependencies. So this Maven repository, you can see there are a lot of projects, there are a lot of libraries which have been released here. So this is a public repository. Okay, so a Java developer who wants to develop an application and wants to get the third-party libraries downloaded, so he can choose this platform to download the libraries from. So this MVN repository is a public repository for Java applications. Now if we talk about JavaScript application, there is a npm.js. This is again a public repository for JavaScript packages. So in JavaScript it is called as packages. So for Python it is pip repository, right? So every platform has got some kind of a public repository. Now it depends upon which public repository you will use, depends upon which application development platform you are using. If you are using .NET, then there is a NuGet package repository. If you are using Java, there is a Maven repository. If you are on a JavaScript platform, then npm is the repository for you from where you can download the third-party libraries. So for any application, this is the first and foremost lifecycle phase. Like if that application needs any libraries, like the classes, methods, which are not part of that environment, let's say a .NET environment, and the application which we are developing doesn't have the methods and classes in it, so we need to depend upon the third-party NuGet packages, right? So you can see here third-party classes are those which doesn't come along with the Java environment. We have taken a Java environment, but this statement is applicable for other language platforms also. Now these third-party classes get implemented, compiled and packaged inside the Java libraries, that is Java jar files, and these jar files are shared with the developers, right? Developers like you, me, and various other developers. So these third-party libs made available on central repository or public repository, for example mvnrepository.com. So this is that mvnrepository.com, which is a public repository where the developers who have developed any reusable libraries, they share it with the fellow developers by deploying or uploading those libraries on this platform, right? Now when you deploy your jar files over here, right? So you need to have, for your project, let's say you are developing a project, a library project, which ultimately you are going to deploy on this platform. Okay, so you need three things. One is group ID. So what is group ID? A group ID of a project indicates the developer of the project. Let's say I have developed a library, so I will keep a group ID as, say, Pranod ID, okay, which will indicate the developer. Artifact ID. Artifact ID is the name of the project actually. Let's say I am developing a calculator API, so I will keep the artifact ID as calculator API. And version. So version is basically the release version of a particular library. So like you can see here, this Apache POI, if we take an example of this Apache POI, so this org.apache is a group ID. Okay, so Apache organization, they developed various projects. Apache, like Apache POI, they have got various projects, various libraries developed. So they release all those libraries under the group ID org.apache. So this indicates the developer. Then in that group, there is a project called Apache POI. So this is one project. Apache POI is one project out of many which Apache organization has, right? So this, and this has got various versions, 1.0, 2.0, various versions. The way we, like any software has, it evolves version by version, right? So similarly, any library evolves version by version. So they have got various releases out here. So there are three fields for any project: group ID, artifact ID, and version. Okay, so when a developer develops a project, he develops with these three parameters. He develops the application, compiles, builds, and then he releases that particular jar file on this platform. This is how this platform is used by Java developers. Okay, this is, and any Java developer who needs the third-party libs, he can download it from this platform. That is point number one. So you have two options. Either you can download your third-party libs, what you need for your particular application. You can download them manually by simply clicking on this link. But downloading a particular jar file will not be sufficient. Why? Because as I told you, like any particular jar file or a project might have various dependencies. Now if you see here, this particular project has got various dependencies. Now simply downloading the jar file for a particular project may not help, may not be sufficient. We may need to download all of its dependencies, and any particular dependency might have few more recursive dependencies. A depends on B, B depends on C, C depends on D. So this is called recursive dependencies. So if I want A, so downloading only A jar will not be sufficient for me. I need to download B, need to download C, also D. So downloading the jar files manually, and that too recursive dependencies, downloading them manually could be a quite effort intensive task. So in this, we can take help of Maven. So Maven helps us in downloading the recursive dependencies from our central repository. Now this is the central repository as I told you, but is this the only repository we can download our jar files from, or we can release our jar files to? So the answer is no. We can set up other repositories as well. We will talk about it once we will understand Nexus. There comes the Nexus actually. But for now, let's say this is the only repository we need to download the dependencies from, and this is the repository where we can release our library to. Then once we get the application like the classes which we need, right? Then the next part is we need to put those jar files into the class path of our project. Now let's understand what is class path. Now this is going to be very important. So class path is like when you are compiling any application. Let's say if I am compiling this class ABC, this is my application class. Now if I am using any third-party class like calculator for example, right? So this calculator class is developed in some jar file. It is developed, compiled and packaged into a jar file, right? Now that jar file, when I would be compiling this particular class, my Java compiler need to know where it can find this calculator in, where it should go and check for the definition of this calculator. Usually Java, when you compile your application and you are using the classes from the Java libraries only, so Java gets those class definitions from its environment, JRE environment or JDK environment. But if you are using the third-party classes which are not part of your environment at all, so those classes are developed, compiled and packaged by someone else, and they have provided a jar files to us. So those jar files we keep somewhere, right? So our compiler should know where are those jar files in which this particular class is defined. We will talk about the class path in more detail once we will implement our application. Okay, but for compiling your application successfully, if you are using any third-party libraries, then those libraries must be present in the class path of your application. So class path, in short, class path is a path which Java compiler goes to and goes to basically to find the classes, third-party classes like this calculator. So where it should go and check the definition of this calculator.class file. If I have kept the jar file on this d:my dependencies, let's say, and inside that the calculator.jar I have kept, right? And in this jar file I have got this calculator class implemented. So this becomes my class path. So inside this jar my compiler will go and it will check the definition of this calculator and then it will compile my application. So for this particular application to be compiled successfully, I need this particular jar file in which the third-party class called calculator is implemented. This particular jar file should be present in the class path of my application. So Maven helps us in building the class path. Maven helps us in building the class path of our application. That is a task number 2 Maven performs. Third thing which the developer does is obviously implementation of the code. He implements the code. Like whatever the application he is developing, he will implement the code. He has got the third-party libraries. Those third-party libraries are in the class path of his application. Then he will implement the code. Once the code is implemented, then the compilation of the code. So like if I am a Java developer, right? So I will develop the application like something like this. I will just create a simple application like this, just a example of compilation, nothing else. So I would say abc.java, and then for compiling I just need to open command prompt. I need to say Java C. If I have any third-party libraries I am using, then I need to put them into the class path by saying -cp, right? So -cp stands for class path, and then I will put the third-party libs into it. Let's say d:calculator.jar. So this is the jar I need because I'm using in my application classes implemented and packaged in this jar, and ultimately my abc.java, the location of my code, right? This is how we compile when we compile it from the command prompt, right? Now Maven helps us in this as well. Like we don't need to fire any Java C command. Now when you compile your application, you need to make sure to access the Java C, you need to make sure to build your class path, and you need to make sure to provide the location of your source code as well. So this is what you need to make sure when you compile your Java application. But if you are using a tool like Maven, you don't need to get into all this stuff. Maven takes care of all these things. Maven takes care of building the class path. Maven takes care of, Maven knows where to find your source code to compile and all. So Maven knows everything, right? So Maven helps us in downloading the libraries. It helps us in building the class path. This is what I'm referring to, building a class path means. So Maven helps in this as well. Maven knows where to get the source code from. We don't need to provide, and it compiles the application. Now when you compile your application, right, a Java application, a Java file, we get what? .class file, right? The output of the compilation process. So Maven compiles, Maven triggers Java C. Maven basically triggers Java C. It compiles the application and it creates the required .class files. So Maven does these things for us. Okay. Then comes unit testing. We are going to see the practical, don't worry. Like we are going to implement one simple calculator application and we are going to compile it, unit test it, everything. But Maven helps us in triggering the unit test cases also. Like when a developer develops an application, he first does the unit testing at his end. If the unit testing is successful, then he creates the build, means the jar file, a library version, and then he gives it to the tester. Then it's the job of the tester to test it the way they want to, right? But on the dev end, developers does the unit testing. Okay, so triggering that unit testing, triggering a unit testing is also something which Maven helps us in. Then ultimately packaging. Packaging means like I have developed the application, this application I have developed, then I have compiled this application, I have unit tested this application, and then the next phase is to build a jar file of our own app, because let's say we are also working on some kind of a library, okay, which we want to ultimately build and release here. This is our release platform or production platform, you can say. This is our ultimate production platform where we want to release our library for our customers. Okay, so for that, the first thing is we need to package it. Package means we need to pack our class files into a jar file. That is a package. Packaging. So this packaging also Maven helps us in. Okay, it takes the class files. So basically once you compile your application, we get class files. Now we want to bundle all those class files inside one jar file. This is called as packaging process. Okay, so Maven helps us in packaging process also. Okay, so creating a package, that is jar file or war file. For web applications, it is war file. For library applications, it is jar file. For EJB applications, it is EAR file. But mostly you would be, you would be either bundling jar files or you would be bundling war files if you are working on a web application. Once the package is created, a jar is created, ultimately what we want to do, we want to deploy it on some kind of a repository like this. So this phase is called deploy. Deploying the application. Application in the sense not a web application, but a jar file, a library which you have developed, and that is something, your product or an application which you want to release, right? So this is the deploy phase. Okay, so Maven will take care of downloading the third-party libraries which your application needs. You need as a developer of your application. So downloading those third-party libs you would be able to do using Maven. Once you get those libraries, you need to put those libraries in the class path of your application so that you would be able to compile your application. So that is something which Maven will take care of. Implementation is something you need to take care of, obviously, as a developers. But once the implementation is done, rest of the phases again Maven will take care of. Compilation of your source code, triggering the unit testing of your unit tests, packaging, that is bundling your .class files into the jar file, and ultimately deploying that jar file on some kind of a repository. So all these things would be taken care of by Maven.